Hello everyone. So today's topic is oscillator. My name is Shivcharan Puri, Assistant Professor, EC Department, Asansol College. So what is an oscillator? An oscillator is a circuit which produces a continuous, repeated, alternating waveform without any input. Oscillators basically convert unidirectional current flow from a DC source into an alternating waveform which is of the desired frequency as desired by its circuit components. The basic principle behind the working of oscillators can be understood by analyzing the behavior of an LC tank circuit shown in figure below. Which employs an inductor L and a completely pre-charged capacitor C as its component. Okay, so this is the working of oscillator. So you can see here at first the capacitor starts to discharge via the inductor, which results in the conversion of its electrical energy into the electromagnetic field, which can be stored in the inductor. Once the capacitor discharges completely, there will be no current flow in the circuit. However, by then the stored electromagnetic field will be generated a back EMF, which results in the flow of current through the circuit in the same direction as that of before. This current flow through the circuit continues until the electromagnetic field collapses, which results in the back conversion of electromagnetic energy into the electrical form, causes the cycle to repeat. However, now the capacitor would be charged with the opposite polarity now, due to which one gets an oscillating waveform as the output. However, the oscillations which arise due to the interconversion between the two energy forms cannot continue forever. Okay, as they would be subjected to the effect of energy loss due to resistance of the circuit. As a result, the amplitude of these oscillations decreases steadily to become zero, which makes them damped in nature. This indicates that in order to obtain the oscillations which are continuous and of constant amplitude, one needs to compensate for the energy loss. Nevertheless, it is to be noted that the energy supplied should be precisely controlled and must be equal to that of the energy lost in order to obtain the oscillations with constant amplitude. This is because if the energy supplied is more than energy lost, then the amplitude of the oscillations will increase, the previous figure, leading to a distorted output. While if the energy supplied is less than the energy lost, then the amplitude of the oscillations will decrease, leading to unsustainable oscillations. Figure A and figure B is here. As you can see, so this is increasing oscillations, this is decaying oscillation, and this is actually the constant amplitude oscillations. Practically, the oscillators are nothing but the amplified circuits which are provided with a positive or regenerative feedback, wherein a part of the output signal is fed back to the input. You will see the figure. Here the amplifier consists of an amplifying active element, which can be a transistor or an op-amp. Okay. And the backfed in phase signal is held responsible to keep up or rather sustain the oscillations by making them for the losses in the circuit. As you can see here, the figure which we are talking about, this is the amplifier. Here will be a feedback and there will be output, and the sustained oscillation will be obtained at the output for this particular arrangement. This is a typical oscillator arrangement. When the power supply is switched on, the oscillations will be initiated in the system due to the electronic noise present in it. This noise signal travels around the loop which we have seen right now. You can see this is the loop. Okay. Gets amplified and converges to a single frequency sine wave very quickly. The expression for the closed loop gain for that loop of the oscillator shown in figure 3 is given as the previous figure we were talking about. G is equal to, this is the gain, A by 1 plus A beta, where A is the voltage gain of the amplifier and beta is the gain of the feedback network. Here, if A beta is greater than 1, then the oscillation will increase in amplitude. We have seen in the previous figure. While if A beta is less than 1, then the oscillation is damped. We have seen in the previous figure B. On the other hand, this is the best condition. If A beta is equal to 1, it leads to oscillations which are of constant amplitude. In other words, this indicates that if the feedback loop gain is small, then the oscillations dies out. While if the gain of the feedback loop is large, then the output will be distorted. And only if the gain and only if the gain of the feedback is unity, okay, then the oscillations will be of constant amplitude, leading to self-sustained oscillatory circuit. Now the classifications of oscillators. So electronic oscillators are classified mainly into following two categories. Sinusoidal oscillators. Now the oscillators that produce an output having a sine waveform are called sinusoidal or harmonic oscillators. Such oscillators can provide output at frequencies ranging from 20 Hz to 1 GHz. Next is non-sinusoidal oscillators. The oscillators that produce an output having a square, rectangular or sawtooth waveform are called non-sinusoidal. They are also called as relaxation oscillators. Such oscillator can provide output at frequencies ranging from 0 Hz to 20 MHz. So non-sinusoidal oscillators are basically employed in the lower frequency domain. Sinusoidal oscillators can be classified in the following two categories further. Tuned circuit oscillators. Now what happens? These oscillators use the tuned circuit consisting of inductors and capacitors and are used to generate high frequency signal. Okay. Thus they are also known as radio frequency RF oscillators. Such oscillators are Hartley, Colpitts and Clap oscillators, etc. Next is RC oscillators. Now these oscillators uses resistors and capacitors and are used to generate low or audio frequency signal. Thus they are also known as audio amplifier oscillators such as phase shift and Wien bridge oscillators. Now these are actually the concerns of ours. Okay, this is included in the syllabus. Now we're coming to crystal oscillators. These oscillators uses quartz crystal and are used to generate highly stabilized output signal with frequency up to 10 MHz. The piezo oscillator is an example of a crystal oscillator. We know that it's used in the watch and all. Now coming to negative resistance oscillator. These oscillators are used negative resistance characteristic, okay, of the devices such as tunnel devices. So tunnel diodes are there. It's not in the syllabus, just to take a note of that. A tuned diode oscillator is an example of a negative resistance oscillator. Now the application of oscillators. Oscillators are a cheap and easy way to generate specific frequency of a signal. For example, an RC oscillator is used to generate a low frequency signal. An LC oscillator is used to generate a high frequency signal. And an op-amp based oscillator is used to generate a stable frequency. The frequency of oscillations can be varied by varying the component value with the potentiometer arrangement. Now some common applications of oscillator include quartz watches used in various audio system and video systems, Used in radio, TV and communication devices. Used in communication, metal detectors, stun guns, inverters, ultrasonic and radio frequency applications. Used to generate clock pulses for microprocessors and microcontrollers. Used in alarm and buzzes. Used to operate decorative lights, example dancing lights. Now we will come to one of the important characteristic of oscillator, which is called as Barkhausen criterion. Now thus it is understood that a practical oscillator circuit consists of a tank circuit, a transistor amplifier circuit and a feedback circuit, as we have seen in the previous slides. From the concept of feedback amplifier, we can derive the gain of the feedback amplifier. So principle of feedback amplifier. A feedback amplifier generally consists of two parts, amplifier and the feedback circuit. The feedback circuit usually consists of resistors. Well, the concept of feedback amplifier can be understood from the following figure. You can see here, this is the figure. Okay. This is the amplifier with gain A. Gain A is the feedback circuit with beta value, and this is the feedback part. Okay. You can see this is the feedback voltage beta V0, and this is the source voltage. This is the output voltage. This is the block diagram representation of a feedback amplifier. From the figure, the gain of the amplifier is represented as A. The gain of the amplifier is the ratio of, so what is gain? The gain of the amplifier is the ratio of output voltage to the input voltage. The feedback network extracts the voltage Bf is equal to beta V0 from the output voltage V0 of the amplifier. The voltage is added for positive feedback and subtracted for negative feedback from the signal voltage Vs. So for a positive feedback, Vi is equal to Vs plus Vf, which is equal to Vs plus beta V0. Now we know that Vf is equal to beta V0. The quantity beta is equal to Vf by V0 is called as feedback ratio or feedback fraction. The output V0 must be equal to the input voltage Vs plus beta V0 multiplied by the gain A of the amplifier. Hence, Vs plus beta V0 is equal, into A is equal to V0, or you just substitute A Vs plus A beta V0 is equal to V0, or A Vs is equal to V0 1 minus A beta. Therefore, V0 by Vs is equal to A divided by 1 minus A beta. Now we want this. Let AF be the overall gain, that is gain with the feedback of the amplifier. This is defined as the ratio of output voltage V0 to the applied signal voltage Vs. Okay, so that is actually the overall gain. So therefore, AF is equal to output voltage divided by input signal voltage, which is equal to V0 by Vs. From the above two equations, we can understand that the equation of the gain of the feedback amplifier with positive feedback is given by AF is equal to A divided by 1 minus A beta. We have seen this. You can see here. Where A beta is the feedback factor of the loop gain. If A beta is equal to 1, you will see here, if A beta is equal to 1, then feedback gain AF is equal to infinite. Okay. So thus the gain becomes infinity, that is there is output without any input. In other words, the amplifier works as an oscillator here. The condition A beta is equal to 1, this condition A beta is equal to 1 is called Barkhausen criterion of oscillation. This is a very important factor to be always kept in mind in the concept of oscillators. Now, tuned circuit oscillators are the circuits that produce oscillation with the help of tuning circuit. The tuning circuits consists of an inductance L and a capacitance C. These are also known as LC oscillators, resonant circuit oscillators, or tank circuit oscillators. The tuned circuit oscillators are used to produce an output with frequencies ranging from 1 MHz to 500 MHz. Hence, these are also known as RF oscillators. A BJT or a FET is used as an amplifier with tuned circuit oscillators. With an amplifier and an LC tank circuit, we can feedback a signal with right amplitude and phase to maintain oscillations. So this is the tuned circuit oscillators characteristic. Now, types of tuned circuit oscillators. Most of the oscillators used in radio transmitters and receiver are a LC oscillator type. Okay. Depending on the way of feedback is used in the circuit, the LC oscillators are divided into following type. Tuned collector or Armstrong oscillator. It uses inductive feedback from the collector of a transistor to the base. The LC circuit is in the collector circuit of the transistor. Tuned base oscillator. What happens? It uses inductive feedback, but the LC circuit is in the base circuit. Hartley oscillator. It uses inductive feedback. Colpit oscillator. It uses capacitive feedback. And finally, Claps oscillator. It uses capacitive feedback too. Now coming to phase shift oscillator. Is there a syllabus? One of the important features of oscillator is the feedback energy applied should be in correct phase to the tank circuit. The oscillator circuit discussed so far has employed inductor L and capacitor C combination in the tank circuit or frequency determining circuit. We have observed that the LC combination in oscillator provides 180 degree phase shift, and transistor in common emitter configuration provides 180 degree phase shift to make a total of 360 degree phase shift, so that it will become a zero difference in phase. So now the drawback of LC circuits, though they have few applications, the LC circuit have few drawbacks such as frequency instability, waveform is poor, cannot be used for low frequency, inductors are bulky and expensive. We have another type of oscillator circuits which are made by replacing the inductors with resistors. By doing so, the frequency stability is improved and a good quality waveform is obtained. These oscillators can also produce lower frequencies. As well, the circuit becomes neither bulky nor expensive. All the drawbacks of LC oscillator circuits are thus eliminated in RC oscillator circuits. Hence, the need for RC oscillator circuit arise. These are called as phase shift oscillators. Understood? So as you can see here, it's a RC oscillator circuit. Now, principle of phase shift oscillator. We know that the output voltage of an RC circuit for a sine wave input leads the input voltage. The phase angle by which it leads is determined by the value of RC component using the circuit. The following circuit diagram shows a single section of an RC network. You can see here, it's a single section. The output voltage Vi across the resistor R leads the input voltage applied Vi by some angle phi degree. If R were reduced to 0, Vi will lead the V1 by 90 degree, that is phi is equal to 90 degree. However, adjusting R to 0 would be impracticable because it would lead to no voltage across R, because it will be short condition. Okay, it is not possible because we want the voltage, and for that we want a load at the output. Okay, therefore in practice R is varied to such a value that makes Vi to lead V1 by 60 degree. The following circuit diagram shows the three sections of the RC network. As you can see here, each section produces a phase shift of 60 degree. Consequently, the total phase shift of 180 degree is produced, that is voltage V2 leads the voltage V1 by 180 degree. Phase shift oscillator circuit. The oscillator circuit that produces a sine wave using a phase shift network is called as phase shift oscillator circuit. The constructional detail and operation of the phase shift oscillator circuit are as given in next slide. Now coming to the construction. The phase shift oscillator circuit consists of a single transistor amplifier section, okay, and a RC phase shift network. The phase shift network in this circuit consists of 3 RC sections. At the resonance frequency F0, the phase shift in each RC section is 60 degree, so that the total phase shift produced by RC network will be 180 degree. The following circuit diagram shows the arrangement of an RC phase shift oscillator. You can see here, this is the RC phase shift oscillator. Now here, the frequency of oscillations in this oscillator is given by F naught is equal to 1 by 2 pi RC root 6, where R1 is equal to R2 is equal to R3 is equal to R, C1 is equal to C2 is equal to C3 is equal to C. Now the operation. The circuit, when switched on, oscillates at the resonant frequency F naught. The output E naught of the amplifier is fed back to the RC feedback network. These output produce a phase shift of 180 degree and a voltage EI appears as input. The voltage is applied to the transistor amplifier. The feedback applied will be M is equal to EI by E naught. The feedback is in correct phase, whereas the transistor amplifier, which is in CE configuration, and this common emitter configuration, produces a 180 degree phase shift. The phase shift produced by network and the transistor add to form a phase shift around the entire loop, which is actually 360 degree. Advantages. The advantages of RC phase shift oscillator are as follows. It does not require transformer or inductors. It can be used to produce very low frequencies. The circuit provides good frequency stability. Now coming to disadvantages. The disadvantages of RC phase shift oscillator are as follows. Starting the oscillations is difficult as the feedback is small. The output produced is also small. Wein bridge oscillator. The second in the syllabus. Another type of most popular audio frequency oscillator is a Wein bridge oscillator circuit. It is mostly used because of its important features. The circuit is free from the circuit fluctuations and ambient temperature. The main advantage of the oscillator is that the frequency can be varied in the range of 10 Hz to 1 MHz, whereas in oscillator circuit, whereas in the RC oscillator, the frequency is not varied. Now let's talk of construction. The circuit construction of Wein bridge oscillator can be explained as below. It is a two-stage amplifier with RC bridge circuit. The bridge circuit has the arms R1C1, R3, R2C2 and the tungsten lamp LP. Resistance R3 and the lamp LP are used to stabilize the amplitude of the output. The following circuit diagram shows the element of a Wein bridge oscillator. As you can see here, this is circuit diagram of a Wein bridge oscillator. The transistor T1, you see here, the transistor T1 serves as an oscillator and an amplifier, while the other transistors T2, this one, is serves as an inverter. Serves as an inverter. The inverter operation provides a phase shift of 180 degree. Okay, phase shift of 180 degree. The circuit provides positive feedback through R1C1, R2C2 to the transistor T1. Okay, and negative feedback through the voltage divider to the input of transistor T2. The frequency of oscillations is determined by the series element R1C1 and parallel element R2C2 of the bridge. Therefore, is given by F is equal to 1 by 2 pi whole root R1C1 R2C2. If R1 is equal to R2 and C1 is equal to C2 is equal to C, then F is equal to 1 by 2 pi RC. So we will take this as R. Now we can simplify the above circuit as follows. You see here, just I made the equivalent R and C. This is the arrangement amplifier 1, amplifier 2 to the 2 resistor, and as we are getting here, it's inverted and finally it is 360 inverted to the normal shape. The oscillator consists of two stages of RC coupled amplifier and a feedback network. The voltage across the parallel combination of R and C is fed to the input of amplifier 1. The net phase shift through the two amplifier is 0. Okay, the net phase shift is 0, as you can see here. So as you can see here, there is a phase shift here and there is a phase shift here. So finally it is a 0 phase shift over here. The usual idea of connecting the output of the amplifier 2 to amplifier 1 to provide signal regeneration for oscillator is not applicable here, as the amplifier 1 will amplify signal over a wide range of frequencies, and hence direct coupling would result in poor frequency stability. By adding VM feedback network, the oscillator becomes sensitive to a particular frequency, and hence frequency stability is achieved. Coming to the operation, when the circuit is switched on, the bridge circuit produces oscillation of the frequency stated above. The two transistor produces a total phase shift of 360 degree, as has been told, so that proper positive feedback is ensured. The negative feedback in the circuit ensures constant output. This is achieved by temperature sensitive tungsten lamp LP. Its resistance increases with current. If the amplitude of the output increases, more current is produced and more negative feedback is achieved. Due to this, the output will return to the original value, whereas if the output tends to decrease, reverse happens. Now coming to the advantages of VM bridge. The advantages of VM bridge oscillator are as follows. The circuit provides good frequency stability. It provides constant amplitude. The operational circuit is quite easy. The overall gain is high because of two transistors. The frequency of oscillations can be changed easily. The amplitude stability of the output voltage can be maintained more accurately by replacing R2 with a thermistor. Now coming to the disadvantages. The circuit cannot generate very high frequencies. Two transistors and a number of components are required for the circuit construction. That's the greatest disadvantage. Thank you so much.